Okay, here's a list of the things I would like to talk about, okay? Composite functions, domain and range of composite functions, and in general, domain and range for any function. Deconstructing composite functions, transformations, linear functions, quadratic functions. That gets us up to the second section of chapter 3. And what you just got, if you got it, is everything up through section 2 of chapter 3. Okay? Okay, so let's just take using the familiar functions. Okay? Now, the composite, and people did quite well with this, f of g of x equals f of 1 over x squared. Well, actually, the way I've been doing it is I substitute into the f function first. It doesn't really matter, but let me be consistent. Okay, this equals then 2 raised to the g of x, which is 2 to the 1 over x squared. Okay? Or you could have written it f of 1 over x squared, and that would be 2 to the 1 over x squared. Doesn't matter which way you write it. Now if you switch and do g of f of x, you get a different function. Okay? With a different domain. So, what's the domain? The most common answer I got for the domain of this function was negative infinity to infinity because, of course, the 2 to the x function is defined all the way from negative infinity to infinity. You can plug any number x into this function and you get a result. Okay? You can raise 2 to any power whatsoever. 2 to the 0 is 1, so you don't have to worry about 0. Now some people also thought that negative 1 and 1, or negative 1/2 and 1/2 were not in the domain, okay? And I think in every case I put a little note in your paper so you can kind of think about that. They're in the domain of the function in general, okay? They're perfectly good numbers. 2 can be raised to either of those powers, but we don't know how to calculate it. So we don't use it when we're doing our basic graph of 2 to the x. Okay? It's not because it isn't in the domain. Unlike, for example, when you don't use 0 to do 1 over x, you don't use 0 because 1 over x is not even a defined number. Okay? We didn't use 1/2 or negative 1/2 for 2 to the x because you don't have a clue how to calculate that. I know how it could be calculated, but if I had to do it by hand to 6 significant figures, it would take a while. And I'd probably make a mistake because there'd be a couple hundred calculations involved, okay? So don't think that a number, that you know how to calculate a number because you know how to punch it into a calculator. We're not using calculators for these at this point, except to check our estimates, right? Which is another thing. If you're using a calculator to get these values, sometimes it was necessary. I'll try to address that. So I didn't complain about it much, but sometimes I said, based on estimates, figure this out, and I got 6 decimal place results. I know you didn't estimate to 6 decimal places, okay? So if it asked for an estimate, and you gave me 6 decimal places, I know what you did, and you didn't do the estimate. You do the estimate from the graph. Also, you want to show me on the graph how you did the estimate. Don't just write down what you think the estimate is. You know, you got a graph there. You can show me a couple of projection lines and show me there's your estimate. Okay? Now, I'm pretty confident the people that just wrote the estimates down probably did that, but you've got to show me. Okay? Make sense? Now, that's a little bit of a digression from this. Okay. So, okay, back to the domain of this. Okay? One thing about the domain, well, we know what the domain of 2 to the x is. It is everything from negative infinity to infinity, right? We can use any number. Or if you were restricting yourself to the interval from -2 to 2, I would have accepted that because I might have specified even, I don't remember, that, on the interval -2 to 2, what's the domain, right? It'd be -2 to 2 for this function, okay? It wouldn't exclude -1/2 and 1/2 just because we don't know how to calculate it. You draw the function, you draw the graph, okay? That curve represents the values that do exist, and you can estimate values from that curve, and there are other techniques for calculating it other than using a calculator, but any sane person, of course, that wants an accurate result would use a calculator, okay? But for an estimate, use that curve. The point of that is, again, you got this curve that represents what that function does. There are no breaks in the function. There's no value of x for which that curve doesn't work. Okay? Okay. So the domain of f of x is this. What's the domain of f of g of x? Does it inherit the domain of f of x because f is the first function? Well, there's one number that we obviously can't plug in to our composite function. What's that?
0.
Yeah, look here. Plug in 0, what happens? The first thing you get is 1 over 0. What's 2 to the 1 over 0? Well, it's ridiculous to ask because 1 over 0 isn't even a number. You can't raise 2 to something that isn't defined, right? So a lot of people miss that, but yeah, that's the point I knew I was going to have to come back to, okay? But a lot of people got it too, so that's pretty good. Now, in the future, everybody needs to get that, because it's obvious, just looking at that you can't use x equals 0, right? Okay? So, two to the 1 over x squared doesn't inherit the domain of 2 to the x. Obviously, I'm just going to say won't work, but it's undefined, and it's so ridiculously undefined that if you think about it, you'll see it's ridiculous to think that x could be 0 for this function, right? Not ridiculous that you missed the fact, okay, because that's easy to miss, but once you see it, you understand that, yeah, it can't be done. Okay, so the domain would be negative infinity, 0, union 0, infinity. Okay? Now, one other thing that I saw, and you want to make a note and correct it. You don't put a closed bracket on negative infinity. Negative infinity isn't a number. Okay? It's an open bracket, meaning the numbers approach negative infinity. In other words, they never stop. Never stop getting further from the origin. Okay? Make sense? A closed bracket would mean that the number is included, right? And you can't include a number that isn't a number. Now, over here, of course, it would be pretty easy to accidentally put closed brackets on the zeros here, right? Of course, that would mean 0 is included, not that it's not included, right? Okay? So you want to be a little careful about that. But I don't see a lot of problem with that. The notations I saw were generally pretty good. Okay? Little details we want to clean up, but everything looks pretty good here. Okay?